Today, I'm going to be talking about generative AI, okay? And basically how you and your teams should actually evolve into the regular use of AI in your workflows, okay? So I'm going to be starting by just sharing some information first about the work we've been doing so far. Okay, 4 years ago, I started a project called Data Science Forensics, which that was before generative artificial intelligence started. And we've been doing what we call today narrow intelligence. Okay, narrow artificial intelligence, ANI, artificial and narrow intelligence, which is basically a lot of topics that have been discussed so far, which is getting AI to do some specific tasks by training models. In that sense, our data science forensics IO site or AI-DFIR.io, they redirect to the same place, will show you information about the tools we've been developing throughout the last few years, and also will take you to multiple conferences where I've been speaking, the RSA conference the last 3 years, the SANS conference, ODCA, ODSC, etc., talking about that specific artificial narrow intelligence field, okay? There is a lot of information there about how to use AI models to find anomalies, to find adversaries doing lateral movement in your networks, to identify malicious scheduled tasks like the SolarWinds attacks and many others, okay? Today, I'm not going to be talking about that. I'm not going to be talking about artificial narrow intelligence. I'm going to be talking about generative AI, okay, which is a game changer. First, I'm going to be giving you some general concepts, so I don't assume that any of you guys have any previous knowledge about that. You probably have done a few queries on ChatGPT in the past. I'm going to be telling you the most important things you need to know about artificial generative AI. And then I'm going to be doing the application of generative AI to DFIR in two different ways. First, in common tasks that you guys need to do generally, that in which AI is going to be very useful, and then workflows, which is more in what I'm interested about. Okay, how can you change your daily workflows at work so AI can replace part of the work you do? We are, once again, as Johannes and Dave said, we are not going to be replacing the human anytime soon, but we can replace some parts of the human from some parts of the process. Okay, just a very quick intro. At this point, there are like 3 vendors, 3 different technologies that are in the market. Okay, ChatGPT, that most of you know, the OpenAI model and tool, let's say, or interface, Llama 3, which is the Meta model, which has the particularity of being open source, okay, and free, and that's going to be important, as you will see later. And Gemini, which is basically the evolution of BART, which is Google's model, okay, Google's tool, so to speak, okay. Each of these, ChatGPT has GPT on the back, the Meta model has Llama, and Gemini is going to be based on the Google model. Okay, there are 3 different models. There are three different backends that are behind the scenes. So one of the most important things that you need to learn when you're dealing with AI is asking questions. Okay, when you interact with generative AI, you need to know how to ask questions to the AI. They're like, for the most part, 3 models that you can use, or three models, like the zero-shot prompt, which is basically just asking the question, okay? The second one is the few-shot prompt, which could be teaching the model with some information that is going to be useful for the answer. And the third one is going to be a little more providing knowledge to the model, okay? So as you can see, there are like 3 different ways in which you can interact with AI. It's important to know that when you enter this information will be actually broken into pieces. That's what we call tokenization. You probably heard about tokens before, because that's how most of the vendors actually charge you when you're using the model. And you can rapidly think about tokens like words, although they're not always words. A word can be broken in pieces to create multiple tokens from a word, okay? So, but just as a general idea, that would be it. It's important to know that an LLM has no memory, that it has trained until a specific date, and that it has a maximum prompt size. That's a technological limitation, and it is actually improving little by little with time. Okay. There are, for the most part, Google and ChatGPT, Google Gemini and ChatGPT are cloud models. You cannot download them. They are not open source. So they are what they are. You can interact with them via let's say the interface, or via an API, as you're going to be seeing later. And if you want to actually do your own training of the LLM, you will need Llama. Okay, Llama is open source. There are multiple versions of Llama, and for the most part, you can use that to use a hosted model. You will need appropriate, let's say, hardware, so you can have the right power to run this. You need to be aware that hosting something locally is always going to be less performant than having something on the cloud, but that's an option if you need it. Okay, so from that point of view, you have two different models. Imagine you want to train a model, a specific model, to understand your EDR and be able to do EDR queries properly, because the generic ChatGPT model or the other models don't support that. So what you could do is input forensic knowledge to the model, input the query syntax of the EDR, input CTI reports, and train your pre-trained Llama 2 to generate your new Llama. And that would be a fine-tuned model that you can then use internally in your organization. Okay. The second way, which is more common, and we're going to be going in this direction because it's easier, is providing the information via RAG, retrieval augmented generation, which, as I was saying, is providing knowledge to ChatGPT or Gemini or Llama through the prompt. Okay. So what you will do is provide information in the prompt via what we call prompt engineering, and then provide your query. The query plus the prompt information, the additional information, will be used by the LLM to answer your question. Okay. So another option, it is common. I mean, obviously the LLMs will not know everything, so you will need to provide this information often. If you're, for instance, if you want to do SQL queries or your own EDR queries, it will most probably be the case that ChatGPT does not know how to do queries in your own EDR language. So what you can do is provide this information about the schema, about the queries, and then provide your query, input that in the prompt, and then it will potentially generate a reasonably good, let's call it reasonably good query. Okay. This means that you still have the human to actually overlook what the results are. Okay. So there are a number. I'm going to be going then to show you some easy ways in which you can use ChatGPT or other other of the GenAI tools for standard daily DFIR work. Okay. So I'm going to be doing a small demo in which you will be seeing rule generation of Jara and Sigma, scripting, analyze of unstructured data, writing cybersecurity reports, which you are going to be loving because none of us like to write reports, etc. So let me open this small demo and let's go for it. Okay. Again, these are small things that you are going to be finding useful. For instance, imagine you have a security event log and you have a number of entries. Okay. And then you want to have ChatGPT to analyze that CSV and show me a list with all hostname IP pairs in the logs, remove duplicate samples. Okay, that's not rocket science. It's easy, any analyst can do it, but obviously it's much more convenient to have just your report, your CSV uploaded and ask GPT for the question. One of the cool things about ChatGPT is that it will, if you click on that small arrow on the bottom, it will show you the code it has actually used in order to generate that output, okay? Which is pretty cool, right? So the next thing I'm going to be doing is show me the full list, okay? So now it's going to be giving me the pairs of IP addresses and host names. And I'm going to be saying, hey, it's a little more complicated, okay? extract the lateral movement grouping by users, show the results in a table with columns, sort host, target host, username, remove the duplicates, and show me the full list. You may say, okay, show me the full list. Isn't that, redundant? The answer is yes and no, okay? One of the things about ChatGPT is like a temperamental human at times, okay? Like a human that tries to give you the result very, very quickly. And that's inconvenient if you want accuracy, okay? So sometimes when and once again, we go to the art of asking, you need to learn how to interact with ChatGPT. You need to learn how ChatGPT is going to be interpreting your question. And sometimes you need to push a little bit ChatGPT and say, I want everything. I want every detail. I want you to take your time. I want you to review the results twice, 3 times. And that's going to be changing. That's going to be forcing ChatGPT to go slower and give you better results. Once again, you will learn that with practice, but keep that in mind. Okay? So here you have a little more sophisticated analysis. Now I have told him to give me the lateral movement, and he's telling me basically what user has jumped from what workstation to another workstation. Once again, this is not rocket science. You can do it on your own. But to be honest, that saved me quite some time this time, right? It was much faster than myself doing it. You just saw how ChatGPT can allow you to actually select different models. You may ask, what is the difference? ChatGPT 3.5, should I use GPT-4? Note that this is the models behind the ChatGPT interface, okay? GPT 3.5 is a little less, let's say, sophisticated, but it's faster, while ChatGPT 4 is going to be more sophisticated, but because it is more sophisticated, it's going to be slower. Also, OpenAI limits the number of queries you can do in the free interface with GPT-4 to even with some of the commercial versions to a number of queries per day. So normally, if you can do it with ChatGPT 3.5, I mean, when the GPT 3.5 model is going to be more convenient. Okay? So I'm going to say, hey, consider the following CSV file. I'm going to be uploading the data, okay, and wait for instructions. Okay, I upload the data and I say, hey, now a little more sophisticated, show all the executable files you find in the logs. I uploaded some logs and I'm going to be telling ChatGPT, and now group them by folder. Once again, not rocket science, but it's something that in your daily work, it could take a little time. As you can see, ChatGPT can do it much faster and convenient for you. It's giving a split second, and then you have all the executables that it has found in the different folders. Okay, PowerShell, temp, etc. And you can very, very quickly see how some of them are very interesting, okay, and very suspicious. So that obviously helps your analysis work. Let's go with something different. Now I'm going to be telling him, hey, I want you to write a Jira rule to detect files with the following features, whatever they are. I mean, you probably are familiar, you're Forensicators, you're familiar with what you need to look for. So you provide ChatGPT with the information. It is a Windows executable, contains some of these strings, and the file size is less than 400K. Once again, this is, if you are familiar with Jira, this is not difficult to write. But let's be honest, it has been much faster than I would normally be able to write it, okay? Once again, it took a split second. Another comment I want to make is, note that sometimes I am assuming that you guys know how to write Jira rules. But what if you don't? I mean, none of us is perfect. None of us knows everything. We don't have all the knowledge. And by default, ChatGPT is going to be providing some of that knowledge for you in case you don't have it. You can do that with, as you're seeing with Jira rules. I'm going to be showing other examples, including reversing malware, etc. It provides generally acceptable results. Okay, let me check here. There you are. So act as a cybersecurity expert and describe the following PowerShell command. Okay, as you can see, here, there is an encoded command, and it's going to be telling you what it does. Okay, so as you can see, that's the invocation, that's the flags, and then it actually automatically undo the base 64 for you, which again, I could have done myself, but it's much faster to do it in this way. And it's going to be explaining what actually it does. Okay, so it says, hello, Forensicators, and it explains what this snippet is doing. Okay, A little verbose, I must say. ChatGPT likes to talk a lot. Let's go one step further. Hey, which MITRE attack techniques correspond to this type of activity? Okay, once again, you can do it that on your own, but you would need to go to MITRE and figure out the enterprise matrix, what it corresponds to. And now it says the PowerShell command you provided demonstrates several techniques which correspond to command share, obfuscated files, bypass user account, defense evasion, deobfuscate the code files of information, etc. Okay, once again, very convenient, very fast. It can help you a lot. I highly recommend you guys that you review the results. You cannot fully trust ChatGPT or any of the other models, but it's going to be speeding up your analysis a lot, as you're seeing. Okay, let's go for another trick. Act as a cybersecurity expert. Which Windows event logs could I review for searching PowerShell activity in my network? Tell me where I can find the logs and what event IDs should I check. Okay, and it tells you a little bit that the Windows PowerShell event log, the Microsoft Windows PowerShell operational, security event log, application and services logs. You may see that probably you can find other sources. Again, these may or may not be complete or completely accurate, but it's going to be giving you a pointer in the right direction and at least a part of the solution. Okay, so now I have these logs. Write a Sigma rule to detect PowerShell activity to download and execute the scripts. And bingo, it is going to be writing a Sigma rule, which is going to be having the basic fields good enough to detect this type of activity. Okay, so far you've seen a lot of the things that it can do, but this is one of my favorites. All of us hate writing reports, right? So what if I pass ChatGPT my investigative notes and ask him to provide the report? So I will do that. Okay, ask or provide the investigative notes, and ChatGPT will actually do an executive summary, timeline of events, lateral movement, indicators of compromise, hashes, okay, and even the recommendations and conclusion. Okay, so to start with, that's going to be saving quite some time of work you probably don't love doing. Okay, so let's close here and let's go to the next mode. When we close here the generic part, and I'm going to be focusing now on something a little more sophisticated, which is going to be workflows. Okay, so far I've told you, or I've shown you different things, different individual things that can clearly help save some time, but that's not really transforming the way you work, right? That's kind of a helper in some of the traditional tasks you do and improving the speed. So let me change to a much more interesting way of doing things, which are agents, okay? LLM agents. That's when you're actually using this Bing or ChatGPT or Gemini. What you're actually using is not an LLM. People think, oh, I'm interacting with an LLM. You are wrong. You're interacting with an AI agent, with an LLM agent. Behind that interface, what you have is actually an agent. I'm going to be showing you what an agent is in a few seconds. Okay, but it's an orchestrator. Think of it as a SOAR for AI, okay? So it's going to be orchestrating, interacting with the LLM, interacting with different tools, going to the internet and doing a number of things, all in an orchestrated way. So you find one of these AI agents, or you can find them in GitHub Co-Pilot, in many other applications. So that's something that you are using when you're using these copilots. I'm going to be, but you can also use your own copilot, let's say, or your own agents, as you will see in a minute. So let me give you a very simple example on how an LLM agent works. So an agent is an orchestra. Well, plan a trip to Thailand in the summer. Invite my friend Paul. So what the agent would do is actually go to these specific tools. First of all, it would ask the LLM what it needs to do. Then the LLM agent would go to Google Calendar to check your free days in the summer. Then it could go to the websites that can help plan the vacation, and it will end up by going to your MS Outlook to send the email. Okay, so in the end, it's a combination of LLM. The LLM is telling it intelligently what it needs to do, and the agent will execute whatever the LLM requires. Okay, let's go now that you understand the agents, let's go specifically to DFIR workflows. Okay, let's imagine a simple workflow which includes CTI, threat hunting, and IR. Okay, imagine the CTI team is going to be searching in many CTI sources for actors and TTPs. It's going to be creating a threat landscape for a specific organization. Then the threat hunting team is going to be getting that threat landscape, designing threat hunting hypotheses, write EDR queries, analyzing the alerts, confirming, discarding the hypothesis, analyzing the results. And then if something triggers, the IR team is going to be doing the triage, run forensic tools, analyze the artifacts. Okay, so that's a common workflow which includes all three things: CTI, threat hunting, IR. How can we actually put this into an AI workflow? Okay, so what you're seeing here are the pieces that actually can be executed by the AI. Okay, like here, here, and here. And the moments, well, you will definitely need a human to take action. Okay, so as you can see, there are some steps in which the AI will, for the most part, do a good job on its own, but definitely the human will have to have a role in this whole process. Okay, so let's go for the second demo. This is going to be about a CTI workflow. Okay, in this case, I'm going to be, oh, wait a minute. No, before I show the demo, I will show you the backstage. So in this case, remember, we're going to be using an AI agent. This AI agent is going to be interacting with an LLM for instructions, and it's going to be able to use some tools. Okay, these tools are things that the agent can go to. In the specific case of this CTI agent, this is going to be the LLM. I'm going to the code. I'm not going to be going to the gory details, but so you have the code in the slides. You can see it later. For the most part, you're going to be selecting what model of ChatGPT you're going to be using, and then you're going to be setting up the tools. In this case, I'm going to be using 4 tools. The ATDA database is the Thailand database of threat actors, which is absolutely amazing. You have some here, the way the agent is going to be finding or looking for that information, even if instructed by the LLM. The second one is going to be querying for information in the Red Canary report. Okay, this is, as you see, a very simple Python script that does that job. Then the third one is going to be using MITRE to obtain information about threat actors. And to end up with, there's going to be a LLM being used to generate the output. Okay, this is how you set the agent. As you can see, it's very easy. I'm telling the agent, hey, I'm going to be using this tool, this tool, this tool, and this tool. And then it's going to be provided in the initialization of the agent there. This is the prompt. And let me go very quickly to the demo. Okay, so what I will do is I will provide the query, okay, which is, I'm a large company with a financial sector located in Switzerland. My environment is like this. The IT team usually uses PowerShell, predominantly always in Windows. We do not use cloud. And taking into account my environment, create threat hunting hypothesis I should consider. So now the LLM is going to be taking that information and telling the agent what tools it needs to execute in order to obtain that information. First is going to be to create the threat hunting hypothesis for your company. I identify main cyber threat actors. It will be using the ETDA database. Then it will be using MITRE for identifying the TTPs. As you can see here, these are the TTPs, okay? And then it will generate the report and give it back to you, okay? And basically, this is the information, the output information. So from that output information is going to be generating the hypothesis that you requested, okay? There are like 8 different hypotheses in terms of how this threat actor could be operating in your environment. These hypotheses are going to be the input for the next step, which is going to be the threat hunting phase. Okay, I'm not going to we don't have a lot of time, but there are different things that you could do additionally with CTI from the point of view of AI and what the analyst role would be. Okay, let me go real quick to threat hunting. In this case, we're going to be using an LLM. We're going to be using a documentation of Velociraptor itself to go search for information, and then a security copilot that we have created at Data Science Forensics to basically manage the output information. This is basically a very quick demo. As you can see, is going to be doing a query, hunt for threats based on the following hypothesis. A malicious actor may attempt to use encoded PowerShell scripts, download and install malware. So then it's going to be going to the Velociraptor documentation, is going to be obtaining what Velociraptor artifact is going to be helping with that. Then it will go to Velociraptor, do the search in our environment, obtain the output, and then that output of Velociraptor, as you're seeing here, is going to be fed to our Copilot, which is a relatively simple agent, which will be parsing the output and giving you the most important information. So here you have found a number of findings regarding certain uses which have been using PowerShell. Okay, pretty amazing. Okay, so all these things has been done automatically by the agent. Once again, you have in the slides the different setup, the tools, the LM, etc. Okay, and once again, you have other things that the AI could be doing for you and things that will be left for the analyst. Let's go to the last step of the road, which could be, okay, I have found something interesting. I'm going to be having the AI to actually process those artifacts. And as you can see here, in this case, I'm going to be using the LLM, Velociraptor documentation, the API, and there is an interesting addition, which is a human in the loop. Okay, so here is search for suspicious executions on this computer. Fantastic. So let's go for it. Okay, as you can see, it's going to be looking to the Velociraptor documentation. It's going to be executing Velociraptor with the right tool, which in this case is going to be prefetch, the prefetch artifact of Velociraptor. Is going to be identifying two different things which are interesting, the PowerShell and the PSExec prefetch files. And then the next thing it's going to be doing is asking you, hey, what do you want to do? In this case, I'm going to be saying, hey, I analyze PSExec. Okay, so it will go on and analyze PSExec output, and it will tell you, I found that in order to do that analysis, I need that specific event log 7045, and after analyzing 7045, I found that there is this malicious activity related to PSExec. Okay, have you seen how amazing it is? The automated way, then you can go on, show me the list of executables that were ran at that specific time, and it will be just doing just so. Okay, so guys, this summarizes a little bit all the amazing things you can do in a workflow. Okay, once again, I will leave this to you in the presentation to look at the code. I know you guys look the heavy stuff, it's there. I will also leave to you to take a look at the things that the analyst can do and the AI can do for you in the workflow. Just to close, take a look at the limitation, okay, in terms of what the AIs can do and cannot do, okay, especially carefully with not completely trusting the AI. It can be sometimes having hallucinations and consistencies, so you need a human to overlook the process, and the risks in terms of privacy, misinformation, biases, etc. Things that you probably have seen in the real world. So to close the presentation, what you should then do is go to your organization, identify how you can evolve, identify a project to transform your AI process, your DFIR processes, introducing AI in these places I've been showing you or other places which match your needs, and then train your teams and know the technology and set up the platform that you need in order to improve that. So I hope you guys have enjoyed. You have the links over here to download the slides and get more information in our datascienceforensics.io website. And thank you very much. Hope it was useful.